Hey guys, so we are continuing our microservice discussion series, and here we are in this section, cross-cutting requirements for security. And so let me put it in full screen mode, and there we go. So security considerations for microservices. Security considerations are better part of design architecture right from the start. It's not an afterthought. A very secured microservices based REST API running in a publicly accessible network would defeat the idea, for example. So first of all, network security comes to mind. External traffic are better stopped in the public part of the network. We talked about this, why, in the routing section, why central routing is critical. Security is one of the criteria. The public part of the network can have secure access through the network access control list, security groups to the private network where your actual application servers or Kubernetes pods are running. Database security, all databases must run inside private subnets. All software upgrades can be downloaded to the database VMs through NAT gateways. If we are using the cloud providers managed database service, patching is their headache, not ours. NAT service, network address translation. We have two choices here. We can bring our own. We can, create a IaaS device in the cloud and implement our own NAT VM there. Or we can, if the cloud provider has a managed NAT service, that will be a lot cheaper. And if that meets our security requirements, it could be a lot cheaper option than owning the NAT VMs on our own. Hardened VMs for Kubernetes knows this. I cannot repeat this enough. The virtual machines images used by Kubernetes for creating master and worker nodes should be pre-hardened. Role-based access control for APIs. APIs that are not allowed to be accessed by external users may also need to be role-based access control. Spring Security is one of the best frameworks in the Java stack. Node.js and .NET Core should have their own as well. Central secure access through API gateway, we already talked about this. JWT OAuth 2 is quickly becoming widely accepted API security standard. The API gateway should be the endpoint enforcing security and passing the access token to individual APIs for validation. Let's move on. Security consideration for microservices. Let's see. Kubernetes secrets. All passwords and URLs to access external services are better stored within Kubernetes as secrets. Encryption, decryption in Spring Cloud. Spring Cloud remote config service provide encryption and decryption endpoints if we choose to use that. Certificate and key management. Cloud providers key management system could be the right choice, as security and rotation of the master keys will be managed by the cloud provider, and obviously they have in their payroll some of the best security professionals. That's something to keep in mind. Data security, availability and backup. Data backup, role-based access, restoration. Availability must be taken into consideration, defined and tested periodically. It's not enough that you have a document for disaster recovery and never run that document, test that document, and when the actual situation appears, you found that your DR document is not reliable. That's not a good thing. Bastion host, all manual access to the production VMs better be done from a subnet within the production network. This is part of the 12 factor as well. We talked about the admin hosts. Security log analysis, security log collection, analytics and reporting from various firewalls must be automated. What's next? Logging. Let's see what we have in logging. As per the best practices, containers for microservices should not be aware of actual log destination, as that tightly couples them to the underlying environment. One key difference between monolithic services running in our own data center and microservices running in a cloud environment is that cloud environment VMs, virtual machines, can come and go. They are running on cheaper hardware, mostly unreliable hardware. That's why the affordability in cost. So we cannot tie our applications directly to the file system provided by a cloud provider. That's not a good practice, and it is also included in the 12-factor apps recommendations. So let's see what we have here. So cloud providers logging services. Many cloud providers, provides an often free service for log analysis. If that service meets our needs, we can use it. Splunk is a commercial log analysis platform that also provides a cloud-based SaaS solution. Our VMs that power our container orchestration cluster like Kubernetes will need to have the Splunk agent running as a client server, architecture. If our ops teams are very, very familiar with Splunk, this is often the best option. Elk Stack, Elasticsearch, Logstash, Kibana are emerging as a strong contender for Splunk and is free. The only downside is you need to keep highly paid professionals to maintain the Elastic Stack. The architecture is quite similar. A Bits daemon agent needs to run in our VMs like the Splunk agent and will push data to the Logstash cluster, which processes the data and ingests it into the Elasticsearch. Kibana is the user interface. Log data retention. Kibana, keeping old data in Splunk could be costly in Splunk and may not be feasible for Elk if we want to keep the storage cost low. One option is to move data older than a certain days to cheap blob storage like AWS S3 or Azure Blob Storage. Google has similar options available. Use actuator for logging. Use the Spring Boot actuator micrometer for counting business and error matrices and report them to the log stream. That's a immense power actuator comes with that many people I have seen are not fully using. Create custom dashboard for target users. Both Splunk and Kibana makes it very easy to create custom visual dashboard for different user groups. Troubleshooting. Before we go into troubleshooting, I would like to stop here and create a new video for troubleshooting. Make sense? And let me know if you have any questions, post comments, and I will try to answer your queries as soon as possible. Thank you. Thanks for listening. Bye.